Case our spreader stoker boiler, Fireside Corrosion. Basically, coal ash has both acidic and basic components. Slagging and fouling properties are related to its sodium and potassium alkalinity content. High sodium potassium gives you the highest corrosion rates on metal radiant heat transfer surfaces. These two also determine, along with the iron and some other makeups of the ash, the melting temperature. So this has a lot to do with the operation of the furnace. Sulfur in the fuel burns and produces SO3, sulfur trioxide. It can mix with moisture on the cooler tubes, air preheater, and economizers to produce H2SO4, sulfuric acid. This is called cold end corrosion. This boiler didn't have a superheater economizer, so this really wasn't a major problem. Your big problem here would be the emissions of sulfur. Pulverized units with air preheaters and economizers on them, you can get into cold end corrosion. You can get the temperature down enough to where moisture starts dropping out in the back passes or plates of the air heater and cause a lot of corrosion damage. Big problem with this boiler was soot blowing. You can't have wet steam. You need superheated steam for soot blowing, no moisture in it. Wet steam at velocities of 300-400 feet per second can cause severe mechanical damage. It's called erosion. High velocity water droplets can erode the steel surfaces of the tubes, and eventually they'll rupture and have a tube leak. Free water can quench tubes and cause cracking. If you don't warm up your headers well for soot blowing, just open up your soot blower and spray water in here. These tubes are hot and you're with cold water. You can cause a quenching problem. Over time, that will cause cracks. Soot particles propelled by high velocity can cause erosion. As you blow soot, you're knocking the soot off the tubes in high velocity, so it can actually kind of sandblast other tubes. Overblowing removes protective oxide layer on tubes. It's not too common. This type of boiler, it was a manual soot blower. Chain came down, floor you'd pull. Then as you rotate the soot blower, it'd open up the steam valve. It'd blow steam as it slowly rotated around, then it'd come back around and shut the steam valve. So as a mechanical operation, you'd blow the steam once or twice a shift. Newer pulverized coal units, it's automatic soot blowing. They can overblow at low loads, but usually it's not an issue. Something to be aware of, that too much soot blowing can cause you problems. Slag from the fuel bed can erode the refractory walls. As your slag has various mineral components, it can react and kind of dissolve the refractory. Especially if you carry your fire too far back, pile a bunch of coal against the back wall. The heat can melt the refractory, and then also the slag can dissolve it. Moisture from tube leaks can increase tube corrosion. If you have a tube leak in here, it can leak for quite a while. Excess moisture goes through and may condense down in various sections, mix with the ash, and produce corrosive compounds. So you may have future tube leaks from small tube leak. Basically, with this boiler, it's fairly simple. You just had to watch. If you knew that what was in your coal ash, you can figure out how high you can run the bed without melting it. Say you get more potassium, sodium, the lower the melting temperature, the more likely you are to have clinkers form, melt the whole bed in one solid mass. Like say iron, there's a bunch of different compounds that'll play into your ash temperature. But the sodium and potassium, that's really big on pulverized coal units. For the precipitator to work, you had to have the resistance of the ash so it precipitate out.